Hey folks, welcome back to a new product unveiling. I'm Ryan Thompson here with the applications team at Rottler, and today, stick around because I'm going to show you how to use this brand new machine that's able to bore and surface blocks and also cylinder heads all in one compact package. For over 60 years, Rottler has been in the boring industry, originally having a machine that looked a lot similar, although it was green, in the Rottler F2B. This is our latest and greatest iteration of that platform, so if anyone is familiar with those or has seen them, used them before, a lot of this is going to be the same, but this is the next step into automation and a combination of two machines into one. A little bit about our machine here is we have a range of boring bars. This uses centering fingers in the bar. The centering fingers are automatically actuated with a motor on the spindle, and we do have way covers here, which means we have an X-axis ball screw, and this is driven by a servo motor. So we're able to store hole locations and then move hole to hole. The machine with that automated centering system is able to automatically engage the centering fingers in the boring bar and float the workhead to center up over each bore as long as we give it locations that are close. I've also got a 10-inch fly cutter here. This bolts into the spindle from our drawbar that we manually engage up top here on the top of the spindle. This machine is available and can be equipped with 10, or like this fly cutter here, or a 14-inch fly cutter. CBN or PCD inserts, depending on if you're doing cast iron or aluminum, and all the range of boring cartridges, inserts, anything you could imagine that Rottler's been making for over 100 years. So we're going to hop right in here, and I just want to give you a walkthrough. I'm going to show you and take you through step by step. We've got an LS block here, and today we're going to, from scratch, program and bore as well as surface this whole bank of this block. So I'm going to hop in here and we'll get started. So with this machine, we've got Rottler's, I call it our conversational block boring software, refer to it often as point and shoot. Inside of it here, we can create block files and add operations, and all these operations are canned, and all we have to do is fill in the blanks. That's things for feeds and speeds, bore length, bore locations. Once we type all that into the control and save our program, we can simply hit AutoCycle and let this machine run over and over again. So to get started in here, inside my control, when I open up my Rottler block software, first thing I'm going to have to do is home this machine. And what I want to do here is I need to create a file for my block. So I'll come over here on the left and type in a new program. Now I can use my on-screen keyboard, and we'll give this block a name. Let's call it LS. It's a 8-cylinder block, V-block configuration. I'm going to click to share my vertical zeros, and the reason why I want to do that is today I want to bore, chamfer, and I'm going to even do an O-ringing operation on this block. And when I share my vertical zeros in groups, what that lets me do is I only have to program bore locations and set zeros in the cylinder bore operation, the first mode. Every operation such as chamfering or O-ringing will share those locations, so I don't have to reprogram them. So that creates my block here. Now on my right side in my mode select, this is where I add those operations. So I'm going to type in and add a couple. I'll click new here, and it's going to pop up a box, and this is showing me all of the operations that I can add to this block file that I can then put information in. So we're going to want a cylinder bore, and I'm going to add a cylinder chamfer. I'll add a cylinder O-ringing, and I'm going to add my mill cycle. Now we'll see this happen later. The thing that makes this special is with Rottler on milling machines, we've always added a lead to tilt the leading edge of our fly cutter by about a thousandth, maybe a thousandth and a half at a 14-inch radius. what this machine does that makes it special from the conventional F10X boring machine is by adding this mill cutter, we've added a pneumatically actuating wedge inside of this spindle base. So what this does is when I go into my milling modes, it floats the workhead and engages that wedge to automatically kick for lead. When I'm in boring mode, it's going to remove that wedge to make sure that my spindle is absolutely perpendicular to my machine base, which will make it so that I can bore true and accurately. So we'll start with our boring operation here. Now, our spindle is keyed, and I'm going to load my cutter in here. So I'll find the engagement. Got to get my drawbar to engage. And then there's a series of holes on this flywheel. I can stick a tool in there, and I just want to tighten this up. And now there's a black knob on top here. This lets me manually extend and retract my centering fingers. Typically, you use a same set of centering fingers for the various bars you would use. We're using our production boring bar today. And just like a lathe chuck, when you put the chuck jaws on, our centering fingers are labeled 1 through 4, and our boring bar cartridges are labeled 1 through 4. So to install those, you want to install your fingers in the matching numbers. And the easiest way to do that is you'll run those centering fingers all the way out, or the tie rod. Insert your centering fingers, let everything click all the way out and hold them in so that they will all be in sync, and then retract them all the way in before we get started. So I'm going to jog this machine over here, and now I'm going to go into my cylinder boring mode over here. Now, the first thing I got to do with any CNC machine, and this one's no different, is it only knows, and any of the numbers on the DRO or the hole locations are based on a datum or a 0 that we set. We need to set our X, which is our left to right location, 0, as well as our vertical 0, which is the Z axis. On this machine, the spindle base itself is on an air float. So there's no Y axis, and that's just there so it can center up. So you have some options here on the control. You have float, neutral clamp, and full clamp. Now, this will automatically float when it's centering. It will go to full clamp, which clamps the entire workhead here down to the spindle base for the most rigid cutting situation that you can have when we're boring cylinders. So what I want to do here is I just want to float my workhead and eyeball it center here in its kind of travel, making sure that I've got, you know, enough room for this thing to center up on this first hole. And we'll eyeball that we're square. And then I'm going to use my hand wheel here in the Z axis to just jog down. And I want to get my centering fingers just in about 1/4 inch into the first hole here. We'll eyeball center. When I think I'm good here, I can turn it back to neutral clamp. Now, what I want to do is there's an auto center button here. When I press that, this will automatically center up over this hole. So that extended the centering fingers and shifted everything to be right dead center on hole 1 here. And when I'm at this position up here, where my yellow X and Z notifiers are here under fixture, if I double tap on X, it'll ask me, am I sure I want to zero the X axis? So I'm going to zero that out, and it'll change my DRO position to 0 now. And then what I want to do here is, while I'm here, is I'm going to come up and I'm going to install my boring cartridge. I'm using a RS322 square insert today, and I can slide this into the boring cartridge. Use a 7/32 Allen key to tighten it up. And for my Z0, what I typically want to do is I just want to have this with the edge of the insert about level, maybe a little bit above 20 thousandths or so above the deck surface. So if I jog down with my Z-axis and just eyeball where the tip of this insert is about level, and again double tap and zero out Z. So that's going to tell it now that X and Z0 are pretty much top dead center of this hole. One more thing to do on here, I want to have my cutter oriented to the right hemisphere of the machine, of this bore. And the reason for that is when this machine gets to the bottom of its bore, it's going to go down and it will stop the spindle, index the spindle to its zero location, move away from that by 10 thousandths and retract back up. That ensures you don't score your bore on the retract. So simply move your insert over and double tap on your spindle and zero that out. So now if I hit move 2 on my spindle here and go back to 0, it's going to return to that location. Just retract back out of the hole. Now, one good thing to do, we're using our V6 V8 fixture here today. This is a pneumatically clamping system. It has a triangular shaped bar that goes down the center of the mains. And this fixture is pretty neat. So not only does it clamp on the mains with this bar, it locates in some regards off of that main. If we're clamping with it like this, then we're on the cap side of the parting line. But what we can also do with this is there's a handle down here on the left side and the bar is relieved. If I slide this bar over with it unclamped and drop it into this notch, I can use this handle to raise and lower left to right across the deck. So it depends on what your application is. If you want to go back to just cutting back to the main line and referencing that and kind of square up this deck, or if you're taking a very small amount of material off and you just want to bore the holes and level off the deck and then mill off of that, that handle and that relief allows you to do just some simple leveling. Today we're going to leave it in its mainline position. So in terms of programming our boring operation here, the general school of thought and what I like to do is I like to think about telling the machine where all of the locations are for my cylinders. That's where it's going to move to in this horizontal plane, and then come back and work my way bottom to top in programming the vertical heights, which are the locations where it's going to engage centering fingers or float, turn the spindle on, turn off. On a first time setup, after I've set my 0, it's a good idea to jog over to the furthest hole here on the left and just make sure that your block isn't extremely crooked. If it were, what I want to do is loosen my fixture here and at least get it, skewed to within an 1/8 inch or so, as long as you've got enough travel. So that's just another thing to keep an eye out. This one's pretty square, so I'm going to move back to hole 1, and I can also just do a move to 0 now on X. And I'm going to move over here to my left locations tab. So in here, you're going to see move, some zeros for boxes, numerical boxes, set buttons, and the ability to turn off and turn on bores. Green means it'll go to that hole and bore it. Yellow means it would be turned off. Hole 1 will be 0, and it's going to be this first hole on the right here. Now, we're working right to left. That means that my hole locations, which are going to be the X values I type in here, are going to be negative values. Now, if you know your block's bore spacing for a GM block like this, it's 4.4, we can just simply type that in. So if I tap on the box and I type in -4.4, -8.8, and -13.2. That's going to give me the locations that this will move to for the holes, and then it will center up on each one of them. If you don't know the bore spacing, that's what the set buttons are for. You can jog the machine over, approximate the center, and press set 2, 3, and 4 for each of these. Again, it doesn't need to be exact. You just need to be close enough so that the machine can engage the centering fingers, float the workhead, and center up on the hole. So that programs our hole locations. If I move over to my vertical stops tab, this is where I want to program the end of the bore, the beginning position of the bore, the centering height where the centering fingers will engage, and my clearance height, which is the height that the machine will retract to when moving hole to hole. So start boring height, I usually start at the bottom and work my way up. The easiest way here, if you've set 0 with the insert, top dead center of your deck here, a tape measure, and you can just tape measure your bore, and whatever that number is, maybe add 60 thousandths just to make sure the insert goes past 100, so whatever you need. The only thing you want to pay attention to is that you're going to have the ability for the boring bar to not run into any main webbing or any casting obstructions at the bottom of the hole. The best way to check that is to jog the machine down without the cutter in and take a look with the flashlight through. If you are running into obstructions, then a production cutter head like this, where the centering fingers are below, would likely not work with that application. In that scenario, we sell the blind hole cutter, and the blind hole bar actually has the insert, the cartridge, below the centering fingers. And what that's going to let you do is you can actually bore blind holes, and the insert will be going down first ahead of the centering fingers. So I'm going to go ahead in here and I will type in the bottom of my bore. On this block, it's about 5 5/8. So we'll click that. Start boring height, I like to be about 100 thousandths. This is the point above the 0 of the deck that the spindle is going to turn on. We can do 50 to 100 thousandths, so let's do 50 today. And for my centering height is just where those centering fingers are going to be when the machine goes to center. So to find that location, again, you want to be about 1/8 to 1/4 inch. We'll go somewhere in here. And I can simply press set on the screen by centering height. That'll record that position. And then block clearance just needs to be up above the deck so this machine can go hole to hole. Again, press set. Couple things to pay attention in here. Check box at the bottom here for index spindle. That means it's going to index the spindle when it gets to the bottom of the bore. Engage auto centering. You have the option to turn that on or off. If you're just cutting one hole or you're trying to run this manually, you would turn that off. If you want to engage, you check that box so that it'll go hole to hole and automatically center. And there is a check box for blind hole mode. If you're using the blind hole cutter, you would want to turn that on. You have dwell options on the left, as well as post-cycle clearance locations if you want to have this automatically move over if you're running production. The dwell being for if you want to do finish revolutions at the bottom, perhaps you're cutting a counter bore. So what I'm going to do now is I'm going to take my cutter out. We've programmed the hole locations as well as the vertical locations now. So all I need to do as the operator here is set my, my boring cartridge here to the diameter I want to cut to. To do that, I can use our boring micrometer. We'll set this on the block today. And I've already set this one up and calibrated it. Okay. Now I know that these bores are about 3.865. So what I want to do here is take my cartridge, and there's a little Allen key, a little set screw inside the cartridge, because the back of this cartridge has a plunger on a spring, and that's how we adjust our diameter. And then our boring micrometer is calibrated on diameter to give us an accurate comparison and reading. So what I'll do here is I will loosen that, and we'll go we're going to go to 3.9 even today. So for as long as our boring bars have been around, if you look inside of our manuals, Rottler certifies all of its equipment to guarantee under 1/1000ths of total runout on roundness and less than 1/1000ths on indicated straightness, so long as you're taking less than a 40/1000ths cut on diameter. So you know, here in this scenario, if we were doing a 40 over bore and we're going to leave 5 on hone, we'll be doing 35. So for a finishing pass, you know, keeping this below 40/1000ths. Now in terms of if you're doing sleeving and you got to take a lot of material, this machine will take up to 150, 160 thousandths on diameter in one pass. So it's always a good idea with these to check. What I like to do is just roll my finger across this and make sure that I'm getting a repeatable number. If everything looks good, I'll take this out and I can reinstall my cartridge into my boring bar. And we'll tighten that back up. And we can move our boring micrometer back up out of the way. Now I'm just going to take a quick look, make sure that my numbers look reasonable, and that does. And what we're doing is now we're ready to go ahead and bore this cylinder. Now, if you're setting up and you want to check things, this is where it's very convenient and nice. With the Rottler control here, I can turn off all of these other bores and just bore the first cylinder. So I'm going to go ahead and install my chip shield here. And we can just drop this down. So let's just bore this first hole, make sure things look right, and then we'll turn that hole off and we'll let it run the rest of them. And to run this now in an AutoCycle, I've got everything programmed, my zeros are set. I need to set my feeds and speeds, and I do that from the set zeros page. Now, typically on these machines, with around a 4-inch bore, 800 RPM and a 5/1000ths feed rate tends to work pretty good, provides a very good finish. If I go back to my locations tab, the icon here in the lower right corner says bore left. When I press that, that's the button that will automatically start running all the parameters I've programmed. If I hit bore left, this moves into position, centers up. and retracts up to that block clearance. I can go ahead and take a look. Make sure everything looks good. And now, this would be where I can pause. I would check my diameter, make sure I'm getting the size I want with my dial bore gauge. And from this point now, this program, if everything looks right, you're able to just run automatically down the line. To do that, we'll turn off hole 1 because it's already completed, and simply turn on bore 2, 3, and 4. Reinstall our shield, just swing it back into place. And hit bore left once again. And now this is going to run through those remaining 3 holes. So once the AutoCycle is finished, I'm going to go ahead and just move this back over to hole 1. I can simply press move 1. And now we're going to go ahead and set up our chamfer. So I'll grab my chamfering tool. I can remove my boring cartridge, set it aside. And I've just got a 30-degree brazed carbide chamfering bit here. And I'm going to back out by pressing Program Select, save my program there, and move over into my cylinder chamfer. Now, we're at hole 1, that same position we stored on our X, and in this chamfer program, which I haven't programmed fully yet, you can see on the screen here that my X0 is stored, and it thinks I'm at 0 now. So that's back to what I talked about earlier, where if you share those groups, you won't have to reprogram for each mode that you want to run. So to set this guy up, what I like to do is come down, make sure my cutter's got enough, landing somewhere in the middle of it. That looks good, so I'll tighten it up. And since this is a different tool inside this program, I do need to retouch off this tool. The way that I like to do that is I'll just come down here till I'm a little bit above it. Let's run it. I'm going to run my spindle at 350 RPM here. And from this page, if I just press double tap start spindle, it'll turn the spindle on. So I want to do that. And I'm going to use the hand wheel 1/1000th increment to just come down a click at a time until I hear this touch off. So we're just touching here. I'm going to go ahead and double tap to zero out my Z and retract back out. Now that I've got my Z0, I'm going to come back in and reprogram, same as before, for the vertical stop. I'll work my way back up. We can say, let's try a 20 thousandths chamfer for starting. Start boring height, again, something above, give it 50. Centering height, again, making sure we're about 1/4 inch in the bore with our fingers. And we can press set, and our block clearance being up above. Now, for my dwell, I'm going to run the dwell at 150 RPM for 2 finish revolutions. And we're going to cut our chamfer at 350 RPM and a 3/1000ths feed rate. Locations, I don't need to reprogram anything. So we're just going to turn on bore 1 again, and we'll let this cut. And from here I can look at my chamfer, and it looks like I need to go quite a bit deeper. So I can now just add an increment to my bottom bore to figure out what I like. So let's go to 40. Let's go to 50. Rebore this. That looks pretty good. So once I'm satisfied with the total chamfer that I'm taking and have figured it out on hole 1, same as before, we'll turn on hole 3, 2, 3, and 4. We'll put this over here, and I can hit bore left. And it's just as before, it's gonna move hole to hole, run this chamfer cycle. Once that's complete, we'll go ahead and move back to 0 again. And then we can go ahead and swap out. Our next thing we want to do today is we want to run our O-ring. So we can use, I have a 039 sized O-ring grooving bit for standard for 40 thousandths wire. And we're going to swap this out, and then we'll go ahead. So we need to set our grooving bit, and we can use our boring micrometer again in the same way as before. So we'll get that set and then swap in and out. So we're going to take out our cutter. We've got our chamfering cutter, and then we'll swap over. Once again, 7/30 seconds Allen key. Set this aside. On our boring mic, it's a 5/30 seconds. Screw to adjust to the diameter we want to cut. We're going to set this one at 4/350 today. And then once again, I'll put my cutter in. Tighten it up. And our O-ring operation is pretty much the same, makes no difference as our chamfering programming and the way we want to cut. So I'll back out of my chamfer program so that gets saved, and I'll move into that cylinder O-ring template that I had started earlier. Once again, I've got a different tool in, so I need to reset the Z0 for this operation. And what I'll do is just jog this down again. And with these, you can use a paper to touch it off, get it close if you want, or do the lathe style touch off like we've been doing. We'll just get close here. So I'm going to start the spindle again. And once again, just click down until I hear it just touch off. And zero out the Z. Turn my spindle off. And we'll cut this just like we cut. We'll run 350 RPM, a 3,000 feed rate. Again, left locations are set. So we just need to program in our bottom of our bore. That's going to be how far it goes below the deck surface. So we'll go ahead and do 0.018, so that's 18 thousandths below the deck surface. Start boring height. We'll keep running with that 50 we've been doing. We want our auto centering to engage. Centering height just as before. Just looking to make sure those centering fingers are at a location they're going to be happy about. We'll set, and block clearance up above. Same thing as before. Dwell can be helpful on O-ring 150 RPM and 2 finished revolutions. We'll cut this first hole and see how it looks. And if we're satisfied with that, turn on the rest of our holes. And let it run down the line. And with that completed, we'll move back to 0. We're going to move our chip shield up out of the way. And that completes our boring, chamfering, O-ringing, programming, and operation on this side of the block. So these programs are now stored in the control, and when we go to do the other side, all we do is we flip the block over, reset X0, and Z0 if we have unequal deck heights, and what we can go do is just hit AutoCycle to run all of our boring, chamfering, and O-ringing cycles. We're going to swap over to the fly cutter now, and we will program our mill cycle. So what I like to do to swap this out is I like to move over to the right side of the machine here, take my screwdriver, loosen up my flywheel. I'm going to remove my boring bar. And we'll set that up here. And now I'm going to take my 10-inch fly cutter. Again, it's got a key, so I always mark these. Makes for an easy install. And then I like to move over here. Lets me balance this with my hand and my knee while I tighten up. And once it's engaged, same thing, tighten this up. Find one of those holes in there for the tool. And on this one, we can just tighten up, providing resistance against the fly cutter body. So now I'm going to hop out save my O-ring, and I'm going to move into my mill cycle. Now, as I said earlier, when I hop into this, it's going to automatically engage the wedge. So my wedge turns on, and now I'm free to move this over. So I'll move my cutter over the block, and what I want to do here is I need to, just like with the O-ring cutter or the chamfer bit, I need to touch off, set my zeros where it's just touching the deck, and then I can program how much I want to take off. So one thing to check before is, especially if you're using the 10-inch, which typically will provide the best surface finish, you want to make sure that you're going to be able to touch each, cross the width of the block. And what I like to do is I'll bring this over, so it's just over the end of the block here, and I can hand wheel down just a bit in Z. And I'll move over in X here. And I'm just going to float this workhead out a little bit to center up on the block. So I'll press the float button, and I can pull this. I just want to make sure I'm even and that my insert is going to be over each side. Now, if you end up running out of travel here on this, likely what happened is that if you position this block in an area that it can't be reached, you always have to move, especially when you go bank to bank. This fixture, at least on the V6, there is a double nut system here at the bottom, and you can put a wrench on that, loosen it up, and actually slide the fixture back. It also has an air float system. If you plug your airline in, you'll be able to float your fixture as well. So we just want to find a nice place where this is going to be able to cover the entire deck surface. Now, when we're in the mill cycle, we aren't going to use the full clamp. The full clamp makes this thing completely rigid. Because we need to be able to move to surface, we want to use the neutral clamp button. So I'm back here in the neutral clamp, and now what I want to do is go ahead and touch off my insert. And same as before, I can bring this down with the hand wheel. Now I usually like to just eyeball with my insert off the block till I'm very close. And same thing, I can turn my spindle on. Today we're going to run this at 800 RPM. I'm going to type in a feed rate of 20 thousandths. These feeds and speeds on this set zeros page, this is for if you're just manually running the machine. So if you turn the spindle on and you tap your X jog button, the machine will just keep running at that programmed spindle speed and feed rate. For touching off, this makes it very convenient. I can turn my spindle on, come down at 1,000ths each time, so I'm just touching, and then tap plus X to back off the part. Once I'm off the part, I'll turn my spindle off, and this becomes my X0, so my start location for this. So double tap, zero out X, we will zero out Z. One thing to keep in mind with this is down here, my wedge button saying the wedge is on right now. When you go to touch this off, you want to make sure that your wedge is on, because that's going to add about 1 thou or so of lead if you're touching off with the wedge off, and then the wedge engages when it goes to do its auto cycle. You'll be taking about 1 thou extra material than you are programming. So the last thing I want to do here is, just like with the setup on the boring, is I want to make sure that I can, get to the end, clear both sides, and then save my end location. So if I hop over, I've got my starting location. If I hop over to my operations tab, this is where I program the auto cycle. Again, this can take multiple passes and you can walk away. What I want to do is I want to move up in Z, just so I'm not dragging my fly cutter. And I can just use the jog button, and I just want to make sure that I'm going to be able to deck this whole block. And what I want to look for is I want to find a location where, when I'm at both the front and back corner, my insert is going to be able to mill the entire surface. We're going to tap up a little bit more. Once I've got my location, I can save this. So right here where it says horizontal end, if I press set, it's going to take that location, -24¼ basically. Now I need to program how much material I want this thing to take off. So amount per pass, let's say for today, we want to go ahead and take 5 thousandths off of this deck surface. So what I want to do is I want to say, okay, amount per pass will be 3 thousandths. My vertical start will be at 0, the place that we touched off. My vertical end is going to be -5 thousandths below that 0 point. And my roughing feed rate, so this has a rough and a finish setting. The way this wants to work is in the bottom here I have a finish cut settings, and I have a finish amount and finish speeds and feeds. My finish amount will be what the machine finishes this surface with. So if we're going to tell it to take 5 thousandths total material, what it wants to do is it says, I need to finish with a 2 thou pass, and now that amount per pass that you programmed above is what it will use to take as many as those for roughing. So I've got my amount to finish at 2. I'm going to type in my finish speed. I like to run on my finishes 900 RPM, and we'll run a 9 thousandths feed rate today. And that's in inches per revolutions. For my roughing settings, I like to run at 800, and we can run this at, we'll run this at 20 thousandths, just to let it eat through it. What I like to do is I set my roughing RPM about 100 RPM lower than my finishing. 2 reasons. One, typically I'm going to run a slower feed rate to improve my surface finish for my final pass. That's the finish that the gasket's going to see. So by increasing my RPM a little bit, I'm usually taking a lighter cut and I'm running a slower feed rate. So it just makes the overall cycle time a little bit shorter on my finish pass. The other thing, and the other reason why, is by giving it just 100 RPM, greater on the finish. When this finishes its roughing cycle, it's going to retract up and move back over. And if we were taking 10, I might be doing, 2 roughing passes, or could be anything that I want to do. Depends on what I program. By having 100 RPM additional in my finish RPM setting is if I'm standing around the shop or I'm doing something else, when I hear the machine increase its RPM, I get an audible reminder that, hey, that thing's going on its last pass. It's probably going to be done in 4 or 5 minutes. So it's just a tip that I like to share. So this gets everything programmed. I've got my zeros set. What I can do here is I'll put my chip shield back in. And just when I'm first writing these programs, I like to move back manually to 0. Okay. And what I'm going to do is from my operation page, I'm going to hit Start AutoCycle. When I hit Start AutoCycle, this machine's going to move to the roughing pass depth, so it'll be -3 thousandths, and it's beginning again to mill across this deck. So our machine has concluded its decking cycle here on this bank. At this point, we have a cylinder boring, a chamfering, an O-ringing, and a decking cycle all stored in our control for future use. To finish this LS block, all we need to do as an operator now is remove the block from the fixture, rotate it around 180 degrees, reset it in the fixture, reset the zeros in our programs, and hit AutoCycle. Typically, we can see boring and surfacing on a V8 with programs written in about 30 minutes. Again, this is the F10XS CNC boring and surfacing machine. This is available in 10 as well as 14-inch fly cutters. and with boring cutter heads from 1.5 to 9 inches on diameter. Hope you guys found this insightful. I hope you enjoyed it. If you have any interest or want to know more, please visit us at rottlermfg.com. You can find this machine there with more information. If you have any questions about any of the operations we did today or any other applications that could be done on this machine, go ahead and give me an email, ryan@rottlermfg.com. As always, happy machining, and we look forward to hearing from you in the future. Take care.